get me on there.
Okay, we're gonna go ahead and measure. How much do we have in there?
Alright, the meniscus is about at 4.23, which is the bottom of the concave.
Okay.
And then we will
Put a little
putting
bit
that.
in here. Not all of it.
Is there, so do we need?
Just until it gets to the bottom like we did last time. Make sure it's not too much. Remember we had to put water in here. Is that good? As you can see with our diluted stock solution, the concave of the meniscus is right on, the bottom part is right on 25 milliliter mark, not over. And then right here in our notebook, we're gonna have Elijah explain some good stuff.
We prepared a stock solution of 0.2 molar copper sulfate pentahydrate and measured it to about the 25 milliliter mark in the volumetric flask. And then we measured out 0.125 grams in total for the copper sulfate pentahydrate.
So this is dilution 1 from the stock solution. We're gonna pipette this into the cuvette. We have to hit this line right here. So
We are now going to clean off the sides of the cuvette so that the machine can get a clear reading.
Alright, clean them off.
And then we will place it in like so,
That's the water.
close like so.
Okay, so now he's gonna click read on the water. So it's zeroed right there, and then we read it, and it's 0.0585. Okay, so now we have dilution 1 trapped in there, and we're gonna be clicking read.
Alright, so we have just read the solution, and we will now open the door and remove the cuvette from the door and close it to be safe.
So right now, we just wrote down all of the absorption numbers that we got right there, and we took it from the reads. There you go. So now that we have all of our measurements and everything done, we're just gonna start cleaning up all of this stuff. We're gonna be pouring each of the dilutions down the sink, money, and then we're gonna wash them out. Please don't splash me. We have all the numbers that we have. We have the absorption rates, and then we calculated the concentration right here of the first, second, and third dilution in the end. With this information, we just plotted the absorbance on the Y, the concentration per molar on the X, and then we just took each of our points and plotted it and got the trend line and then the slope.
Here's Beers-Lambert law. The A stands for the absorbance after we get those measured values, and E stands for the molar absorptivity, which is basically the slope, and then the L is 1. So you can basically just multiply the value times 1 to get your final concentration. Harrison, explain those numbers.
Basically, what we did is we just took the absorbance and divided it by the molar absorptivity to get C, because as you see, we had to rearrange the equation right here to go from A equals ELC to A over EL equals C, and then that is our C right there. 3. So basically, the reason that you're going to want to use try across different wavelengths is because some wavelengths of light will be absorbed differently inside the solution. For example, we use 560 on this, but if we would have used maybe a different wavelength of light, like 630, it may not have had a really good absorption rate with the water, and we would not get really clear measurements.
And the lambda max is simply the wavelength that absorbs the most light.